right, so thanks for coming to my talk, you guys. My name is Michael Kennedy. I work for Developmentor. We're a training company mostly focused on .NET and Microsoft technologies, but as you can see, Python, Mongo, also other technologies. So what I want to talk to you guys today about is initially some sort of NoSQL general stuff. What is NoSQL? Why do you care? It's really a fantastic set of technologies. But a lot of times people talk about NoSQL and it's like this high, fluffy stuff, and you leave excited, but you don't actually know what it is you're excited about. Right? So in this talk, we're going to build applications that talk to our database and sort of do all the cool stuff that is NoSQL. And we're going to choose a particular database because if you try to do something concrete, you have to choose a database. The most general purpose, most useful type of NoSQL databases are this class called document databases. And of the document databases, one is vastly more popular and sort of used throughout the world than the others, and that's MongoDB. Right? Now, we'll talk about that a little bit more in detail. So we're going to look at MongoDB, and we're going to use Python, because that's what the guys at the conference wanted. But like I said, I do a lot of .NET as well, so if you have C# questions and want to know how this works in C#, I'm totally happy to talk about it. So how many of you guys out there are using some sort of NoSQL database now? A couple? What are they?
We use it for conversations and messages.
Right, Mongo?
Mongo, sorry. Yeah.
Yeah, sure. Okay, awesome. Mongo. Cassandra, okay, yeah, Cassandra is definitely in there. Not a document database, but yeah, definitely a NoSQL database. Was there one more hand? Don't want to leave. Yeah, you guys, you Node? For autonomy?
Yeah.
Okay, and that's with Node?
No, autonomy being a product.
Oh, autonomy is a database. Yeah, I'm not familiar with it.
We're going to get rid of it. So.
Oh, okay, yeah. That's probably, this is actually more popular than that. Okay, so what are we going to talk about today? Whoops. Sort of latency. So we're going to talk about NoSQL sort of in general, the high theoretical stuff for maybe 30 minutes. Some motivation and where it came from and why you care about it. And then we're going to start building some apps. We'll see how you install MongoDB. Turns out to be pretty simple. We'll talk about how do you create objects or documents in the nomenclature of MongoDB. How does that map to and from your application? How do you query it? We're going to use something called Mongo Engine, which is sort of a little bit like the C# driver as well. We'll talk about the similarities there. And we'll see that MongoDB has its own special set of operators for doing sort of high-performance, concurrent modification of documents. So we're going to talk about that at the end. Okay. So here's how I see the world. And this worldview is slightly changing, but not so much. And it's that I have data, it goes into a database, a relational database. Now let's talk about the architecture. Now let's talk about how we're going to build our app. Right? But first of all, we have data, it goes in a database. This is not a conversation that we have. This is not a choice you make, right? It's basically an axiom. Right? Remember, an axiom is something that requires no proof. It's so self-evident. It's clearly true. I have data, it goes into a relational database, and then we'll go from there, right? So, when was the last time you thought about, well, is a relational database the right choice for my application? Maybe it is. Sometimes it definitely is. You'll see, surprisingly, it's a suboptimal choice, right? Like I said, these document databases are very, very good at being general databases. They're not like these sort of one-off type of, key value stores that you can use in certain scenarios and so on. So it's an interesting comparison that I think we'll draw. So, if starting from a relational database is basically a given truth of current software development, why is that? Right? Why is these relational databases, why have they stuck around for so long? Well, first of all, there's people have experience with them, so they're comfortable, and who wants to go messing with their data? They know that they can take these things and make them, reliable and durable and all that sort of stuff. Many of the tools we have talk to SQL or relational databases. Right? If I open up Visual Studio, there's a whole Server Explorer section where I can go talk to various databases. We're going to use a tool called PyCharm, which is like the Python Visual Studio. It has the ability to open up relational databases and look at the structure. None of them have this for these NoSQL databases, not yet anyway. Tools like Redgate's tools, all of these things are, it's a very rich ecosystem around these relational databases, and that's a good thing. Okay. They also sort of have this ACID property, generally nailed, right? SQL Server, Oracle, those guys, MySQL, they definitely have ACID down, so atomic, consistent, isolated, durable. Right? These are things that you need for highly concurrent data-driven applications. So database, DBAs, database admins, sometimes, they've been doing that for 20 years, and right, it's their job to take care of the data, and why should they go get some funky database when, their world is SQL, right? So that can definitely be a reason that we're still using it, and we haven't stopped using it because the guy who's the DBA says, I don't want to use something else, right? They do a lot of, they help us a lot with concurrency, right? So as long as you put something in a transaction, more or less you can kind of use the database as your thread safety, right? Isolation level serializable, and off you go. And they, not so much these days, but traditionally have been used for what Martin Fowler calls integration databases. So let's talk about that bit a little bit more. So, you can imagine a scenario like this, where these different applications need to share some data. One way to do that is just have them all talk to the same database, right? And this sort of model is called an integration database, and it turns out to not be super flexible or awesome, right? If I want to make a change to this, like how hard is that to get done, right? That's a meeting, probably a tough meeting to get something changed in there, right? So obviously people are moving away from this, right? So where are they going? Well, these databases obviously have tons of complexity. So where are they going? They're going towards these things called application databases plus services. All right, so if instead of connecting through the database, we connect through some sort of service layer, that could be direct HTTP sort of web services or REST services, or it could be service bus, it doesn't really matter, right? But somehow the different parts that control the different silos of data, right? If those are connected with services, then they have more flexibility with what they do with their data, right? But that said, these application databases don't have no reason to think that that's going to be a NoSQL database. It's just a different database that maybe is simpler, right? So maybe your story looks more like this. All right, here we have these different bits of data, and we need to communicate across these different apps, but each app has its own database and sort of does its own thing. Right? In this world, though, then it becomes possible to make different choices about how you treat your database. Right? Security doesn't have to be as tight. Your application can do a little more in the enforcement. Concurrency can be controlled a little bit more in the app. If you would do something crazy and choose a database that has no schema or schema-less, like one of these NoSQL databases, the application structure, if there's only one app talking to it, can create what's called an implicit schema and enforce that for you. All right. So in this world, you can make more interesting choices, like these guys could use a NoSQL database, these guys could use like Oracle, they could use, maybe this is Mongo, maybe that's Cassandra or something, right? It doesn't really matter once you're talking over services, right? So moving this way means these sort of smaller teams can make more interesting choices about their data. All right, so we're talking about NoSQL, but I haven't really told you guys what it is. And if you go looking for a definition, it's a little bit challenging to find a clear definition. You'll hear some people say things like, oh, well, NoSQL means not only SQL. No, it doesn't. That's a nice worldview that we can have these choices, but that's not what NoSQL means. That's not why it was created. I'll tell you about the history, and then you guys can decide if not only SQL means it. For example, well, maybe it means that there's no relational database. NoSQL means no relational database, right? That's probably not concrete enough. For example, in my kitchen, I have a toaster. It doesn't have a relational database. Is it a NoSQL toaster? Probably not, right? So what is it? Well, if you look at the history of the term, back in 2009, a bunch of guys who were working on building database systems that could be distributed somehow across clusters, basically working on horizontally scaling databases. Cassandra, big table, all these guys. They met in San Francisco, and there was a guy who was going to it and said, look, we need a hashtag so we can talk about our meeting. And this guy named Eric Evans, not of domain-driven design fame, given this is an architecture conference and all, but a different Eric Evans, proposed #NoSQL, and that's where the name came from. All right, so those guys were meeting to talk about database systems that were sort of cluster-friendly. Right, so that's where my definition of what NoSQL comes from, sort of the history of this whole thing. And I would say these NoSQL systems are database systems which are cluster-friendly. They can be horizontally scaled, and they trade inter-entity relationships across records for simplicity and performance. Right? So if you're trying to create like a horizontally scalable database and you need to do a join that goes across 100 servers, and there's 100 different servers doing IPC, that all of a sudden becomes a really bad idea. Right? So you need to make certain trade-offs. Right? And you'll see that most of these databases have made those trade-offs. All right, make sense? So like I said, we're going to use MongoDB. Why? Well, if you go out and you compare who's using MongoDB, what is the ecosystem for MongoDB compared to the other NoSQL databases, you'll see it is unlike the others in some pretty obvious ways. Right, so here's the Google Trends, one way to measure popularity of databases and ecosystems and so on. GitHub might be another valid one. Look at the forks and stars and watches and so on, clones. So here's MongoDB. This little flat line here, this is Raven. A lot of people in .NET talk about Raven as a competitor, not really. Here's Couch, sort of slowly trending. And here's Cassandra, which is actually the number 2. Okay, so these slides are up there. You guys can click the link and explore this yourself, right? But this trend has been going this way for a while, and it continues to be. MongoDB happens to be the company, the most valuable startup to ever come out of New York City, valued at like $1.2 billion and growing quickly. So if you're going to bet your company on a product, you would hope that that company would still be around, right? So anyway, they're a pretty solid bet. So let's talk about scaling really quick. Typically, relational databases scale like this, right? Start out with a small server. It needs to go faster, so you get it super fast drives. You get it lots and lots of RAM, many, many processors. And that's expensive, but you can do it. Right? There are ways to horizontally scale relational databases, but you give up much of the relational component of it, in which case, why not just use something that's built for that? Anyway, this is typically the way that it scales, and it's kind of painful, and it has upper bounds and all that. On the other hand, these databases, these NoSQL databases, are built around the idea of horizontally scaling databases. Right? So they don't have certain things that can make this challenging, for example, joins. Right? So you'll see that you don't have joins, but you kind of do. Kind of don't. You don't have explicit joins, but you get super simple horizontal scalability. In MongoDB, to scale out, basically you can start out with a single server, and then you can create what's called a sharded cluster. That's one way to scale. And then you can basically put 10 or 20 or 100 of these servers in there, and then there's one that sort of is the broker of this cluster, right? And you just point your app at that, what's called a Mongo S, a shard server, right? So from an application perspective, you don't care whether or not you're doing horizontally scaling, right? It's purely an infrastructure sort of choice. It's open source. You can go download it on GitHub. Go clone it. It's written in C++. So if you want to get a hold of the server, there you go. Go download it. How do you install it? All right. Well, how many of you guys have experience with Mongo? Like a couple of you guys already raised your hand. But all right. So let me just show you this really quick here. So I've already downloaded this because I don't trust the conference Wi-Fi, which is this one. All right, so here I'm installing MongoDB. Here you can see there's these bin folders. Here's a sort of management console. Here's the server. So MongoDB is now installed on my machine. I might want to set some settings so that it auto starts. All right, so I could come over here, and let's just copy folder path. So if I say, make that bigger for you guys. By the way, Windows 10 has a fantastic new shell that is much like this. Finally, you get cool things like this. So here we have these files. If I want to install Mongo, I basically have to set up a folder. Right? The default is data/db, but could be anywhere. So let me kind of make it writable. And then I can just say mongod --db path is /data/db2. And then --port is, I already have it running as a startup, sort of auto-starting service, so I need to choose a different port, otherwise you wouldn't have to stay that. So there now MongoDB is installed and running, right? Super, super easy to do. You can set it up as a Windows service. At Developmentor, we run both develop.com and our online training stuff all through Mongo on Windows servers running in EC2, right? And we just register Mongo as a Windows service, and it just starts and stops just like SQL Server or some other database would, right? You can do the same thing on OS X. I can show you guys how to do that if you care. Okay. So it's super easy to set up. It's free. It's open source. It has commercial support. It's a really, really nice ecosystem. Okay, so let's talk about what goes into these databases. You'll see that MongoDB itself does not have some form of schema. As it stands today, you can have what you guys would think of as a table. In MongoDB terms, they call it a collection because it's technically not tabular, right? So why call it a table? But in these collections, you can put all different kinds of disparate data. It would be a bad idea, but there's nothing in the database that says you need to. You can do interesting tricks, and you can do like inheritance and stuff like that for your entities, and it makes it really easy because the schema stuff sort of lives in your app, right? But Mongo itself doesn't enforce it. What they're looking at in the future is they're looking at the ability to put constraints on these collections to say these 5 values or this subdocument or something must exist if you're going to insert into this particular table, right? And this one must be an email, and this one must be a number, and so on. So there's going to be something like that coming in the next major release, probably version 3, I'm not sure. So right now, there's no real schema. But if you look at an application, like, let me show you some of the management tools here. So the best management tool you will find, by far, is this thing called RoboMongo. It's this cool UI plus this command shell that is sort of the way that you talk to Mongo. So this is a free open source tool. So I can come down here and let's look at Developmentor. That's an example that's easy. So if you go over here to develop.com and you were actually on the internet, you would be able to go there and see classes and so on, right? So over here, let's go look at this. Why are you not responding? There you go. Make this bigger. Can I zoom? Yes. Okay. So if we look in here, you see like here's our, like I said, what you guys think of as tables, but they're called collections. And we can come over here and there's a JavaScript, not SQL, not T-SQL, JavaScript API for natively querying MongoDB. The documents themselves are stored in a format called BSON for binary JSON. But when you look at them, obviously you don't read binary. Well, maybe some of you guys do, but I don't read binary, I read text. So they convert it to JSON, but it's not actually stored in JSON, it's stored in a binary tokenized version of like an extension of JSON. So here you can see our course. This is like literally if I could open up develop.com because I were on the internet, something you typically do in this century. I would go there and you guys would see this information, right? This is live out of our database, other than it's a copy. Right, so what's interesting about this? Let me page down. There we go. Go up a little. Up, up. So here, yeah, there we go. So here we've got a primary key. We've got things like you would see in a normal database. Let me go. I guess it's good enough. Things you would see in a normal database, like sort of column value, column value, column value. Like these are all standard. But if I go down a little bit, notice this. It's hard to read with the font, but it's open square bracket, close square bracket, right? That's an array. Let's go down here to, what is this, our C++ class. It has more interesting stuff. So here's a column, if you will, like, in quotes, of course, a column in our document, and it's an array of something, right? This would normally be a normalized separate table in a foreign key traversal, right? Apparently, I'm going onto the internet that way, thanks anyway. Right, this would be a foreign key traversal to another table that's called engagements that has a primary key to the course, right? But we don't have that. So what we have is just, this is a, curly brace in JavaScript means object. So here's a sub-object that's nested within, right? This would be a record that were in that other table. You can see that there's a bunch of them, right? Here you can cross over. It used to run on SQL Server, and that's sort of a migration field that's left over. You can see within that sub-document it actually has, right, this class never ran or something, so there's no students in it. But you can see even within that sub-document there's sub-documents. Right? So you might think this is like XML in SQL Server. Like, remember they had that XML column type that you could put that in there, and then you could do XPath against it? Not the same thing. Like, you can technically store blobs in SQL, but can you index deep down inside that XML document? Can you create an index? If this were a whole blob, a JSON blob in SQL Server or something, could you create an index on the student count, which is contained within the statistics, which is an array of items within that document? No, right? But here, you can do all sorts of cool stuff like that. Okay, so I can go and I can create an index, so I can do a high-performance indexed query. Now, I have another example here. Let's look at this really quick. Then we'll write some code. Okay, so this is just like a little sample database from a class on MongoDB I put together. About this is about performance, this bit. Now, I have a whole talk at the end of this conference in the last session about scaling and performance and NoSQL and so on, but that should not be your first concern when you think about whether or not it makes sense to use Mongo or document database in general. What you should be thinking about is, does this make my life simpler? Is it easier to build my app? Things like that. And what you'll find, excuse me, what you'll find is this style of programming is so much easier than working with relational databases. You sort of make a change to your classes, and the database just typically adapts. Okay? Whereas, you don't need migration scripts and all that kind of stuff. Every now and then you might need one, but not so much. So we all have a, it is too hard to maintain my software problem. We don't all have, I have, 5 terabytes of data and I need sub-millisecond query times, right? These are not common problems. Even that's why people get excited about NoSQL. What really is the value is the simplicity of these sort of documents, okay? But that said, suppose I want to go in here, and let's just go down a little bit. You'll see that within these books, people are rating them, okay? And let's look at this particular user. All right, this user's rated, this is a 6. So we've got a book. The book contains an array of ratings. The ratings has a property called user ID. So if I wanted to ask the question, how many books did that user rate, I would write something like this. Not in .NET, not in Python, but in the native queries syntax, this is what I would write. I would say ratings.userid. And that, remember, this is an array. This is a property of the objects contained within the array. And I would say that is an object ID of that. Okay. Now, when you work with this from C#, use link, and link translates into exactly this. When you work with it from Python, you use Mongo Engine, you write some sort of query thing in Python, and it translates in exactly to this, okay? So, first of all, there are 271,000 books, and within those books, in the arrays, and sort of repeated, there's 1.2 million ratings. The very first time when this database is cold, it took 29 milliseconds. But if I run it again, it takes 1 millisecond to answer how many books did this person rate? Well, there's actually retrieving them. If I just want to know how many there are, I would just say count, like this. And I would run it, and I would get the answer. They rated 87, and it took less than a millisecond to tell me that. So definitely an interesting type of system. When people first see these things, they're like, oh, this is kind of like those XML types I can just nest in relational databases. No. It's kind of like that, but it's not, right? Because you can actually make that deeply part of your query. And I really apparently need to get on the internet. Sorry, hold on. Dun, 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 dun. Okay. So that's pretty interesting. Let me zoom out. Not out. Make sense? All right. So how are we doing on time? Pretty good. Let's talk just another minute or two about this. Then we'll go write some code. So in Python, if we want to talk to MongoDB, there are many choices. There are also many choices in .NET, and they're on NuGet, and they're open source. So in Python, you have a couple of choices. You have this thing called Mongo Engine. Well, at the very low level, you have something called PyMongo, all right? Now, PyMongo is the native driver that comes from the MongoDB people, and it gives you basically dictionaries of these objects. It's very low level, right? But if you're going to map classes, you would use something called Mongo Engine here, or in C#, you would use something called the official C# MongoDB driver. These things that talk to MongoDB, in their nomenclature, they call these drivers, right, these libraries. So you can go get that off of NuGet. They're making major changes to it, and it will be out pretty soon. But it's good as it is. So we're going to use this one called Mongo Engine, 1, because it wins the popularity contest, 2, because it works on Python 2 and 3, which is a big deal. If you guys are coming from .NET, maybe you don't realize that's a big deal, but it is. There's other choices like MongoKit. It's kind of popular, but only works on Python 2. SourceForge switched over to MongoDB, and they released the underlying layer they used to do that. Lots of different choices. Again, like most everything you'll find in the MongoDB ecosystem, it's open source, right? PyMongo is open source. The official C# driver is open source. If I were on the internet and I pulled up GitHub, you would see my recent history full of changes from what those guys are doing right now. There's actually 3 people who work at MongoDB full-time whose only job is to work on the C# layer, right? So that's pretty encouraging for .NET. There's one guy who works on the Python stuff. Okay, so like I said, most of this is almost exactly the same in C# versus .NET, versus Python. But the idea is you take these classes and you define classes, and then you serialize them to and from the database. And they can be almost any shape you want, except for you cannot have circular graphs. Right? You can't have circular references because JSON doesn't support that. But you can have sort of interesting nested types. And ultimately, all these classes you define become fundamental types: strings, integers, date times, so on. Okay, so here's an example. We could create a book here, a class called book, and it derives from document. And it has a couple of fields: title, ISBN, author name, whether or not it's popular, and the reviews, and this is a list. Okay? And it's a list of book reviews. Here's what a book review looks like. It has a reviewer, a comment, stars, and it has properties. The properties are not saved, just the sort of the field types that we define explicitly here. All right? So the top level stuff is a document, which basically means it has a primary key. And the embedded things, they don't have a document. They don't correspond to tables or collections and so on. Okay, so let's go over here. And let's open PyCharm and look at this. I have a little bit of a starter project. And by the way, you guys can go to GitHub and download this whenever I push commit to GitHub, right? All my presentation demos will be up there pretty much right away. So we're going to have a simple little program here, and we're going to do a couple of things, sort of sketch this out for you. First, we're going to set up how we talk to Mongo, right? That's obviously required. Well, technically, it could default to localhost 27017, but it doesn't. So At least you need to say the name of a database to get started. And then I'm going to load up some data. And what we're going to do is we're going to use like an airplane scenario, maybe because I've been traveling too much lately and so on. But we're going to create some airlines and some travelers and flights, and we'll put people on those flights and so on. It's sort of a nice, understandable but sufficiently complicated model that we can do something interesting with it. And then we'll do things like, suppose we're running a website, we'll register a new user, we'll let them book a flight, we'll let them check the status of their flights, things like that. Okay. Now, this is not really a website because I wanted to keep it simple. Considered building a website, then I deleted it because I want to just focus on the data access, right? But obviously, this is typically used in the sense of, along with a database. So we're going to start by saying, basically add reference to the library, which in Python, you say import. So you say import Mongo engine, and then you wait. Because PyCharm has this cool feature that it like analyzes all your code, but it for some reason waits until you type a few characters to understand the entire Python structure or whatever. Now finally it's done. Okay, so down here, we'll just go over here and say Mongo engine dot register connection. And what do we want to do? Well, the first one is going to be, you can have multiple connections. So we're going to say this is our default connection. And then we're going to say the name of the database, SA Flight DB, as in software architect Flight DB, whatever. And then we'll say the host equals something. Now, it could just be the machine name and there's a bunch of other properties, or I could say, use this sort of scheme-based connection string here. And I can put authentication, I can put server names, ports, database names, all sorts of stuff in here. So I'll say that, and I could probably put the database. If I was connecting to a cluster, like a replica set, I could put information about that. There's all sorts of things I could put into this, right? So this is much more sort of functional than just a simpler way to say the machine name and the port, okay? So once I say this, then for the rest of my app, I can sort of talk to the database, and it will use whatever I've set up as the default, unless I explicitly give it a different connection. Okay. So the next thing I want to do is come down here and load up some data. Now, I sort of pre-typed, can't find that really. I pre-typed some data that is related to each other so that we can do interesting queries. I didn't want you guys to have to watch that. Oh, actually, before we do that, we need to define some models. So let's go to our database, or let's go to the thing that defines our schema and set up what we want to work with. So we're going to have a customer, and a customer is going to be something we're going to put into MongoDB. In C#, you don't have to do this. In Python, you do. So I need to say this is a document, and of course I got to add basically a using statement. So I'll say from Mongo engine import star. Right, now that's happy. So this is going to be a top level thing. It's going to create a collection, and I can control that by passing a dictionary of various things. What's the name of the table or collection? What type of indexes do I want to use? All sorts of information like that. So I'll say collection equals, and we'll call this customers, plural. It could be anything, right? Paying people, make up something, right? That's the name of the data, the table or the collection. And then I give it fields. So maybe we want a first name equals, it's going to be a string field. And I can say this is required, yes. And then I can say I want a last name. And then let's say something more interesting, like maybe this person has an address. And this address is actually an embedded document of something called address, like address as in that class, right? So instead of saying I want to have two tables and I'm going to do some kind of join, you can't technically do a join in the server, but you can definitely do a join in your app. It's very common. Have these sort of related two separate tables with related entities. What we're going to say is typically when we access the customer, we usually want to have their address. So it probably makes sense to put the address in the customer record, so that's a single primary key query rather than multiple database calls. You got to think about how your app works and whether or not that's a reasonable trade-off. Because this makes getting a single customer slower. Granted, you guys saw like milliseconds slow, like 1 versus 2 milliseconds, but something like that. But it does have an effect. And if you put too much data in there, it can be a problem, right? So if you have 100 megs of data stored in one record, that's going to not be good, right? If you have a few K, if you have a few 100K, it's probably fine. It's a trade-off you got to make, all right? But in this case, we're going to say we're going to embed it, and maybe this has things like similar to this. Oops, didn't really mean to cut it. We're going to come over here and say, this has a street, city, country, and postal code, something like that, right? And if this is going to be embedded in the Mongo world, or in the Python world, this has to be an embedded document. Right? You'll see, because we're doing this, it has all sorts of interesting change tracking, and it only updates the parts of the document that you update when you push it back to the database and so on. So here we have a customer. Let's do the airline really quick. Let me just snatch a few of these things. I thought about having these just built out for you guys, but at the same time, I think it's good to see how you build them up. So this is just going to have a name of the airline. That's pretty straightforward. Probably that's a little bit overkill to have its own table. It would have more data. Over here in this flight, I may want to change the name of customers here to airlines, something like that, and this one to flights. Okay, so this is going to have different things like a number. I don't know why they call them numbers when they have things like UA172, but I'm going to stick with that what they're doing, so it's called number. And then it has a few other things, and because of my pre-built data, it has to sort of line up. So it's going to have an airline, a start city, end city, delay in minutes, and connections. Okay, so let me just put those in really quick. So start city, end city. This is so you can say, I want all the flights that go to London. I'm going to have an airline. I can do something interesting here. I can say this is a reference field to another collection, and it's going to be an airline. And I can even say the reverse delete rule. If somebody deletes the airline, cascade. If somebody deletes the airline, also delete all the flights from the airline automatically, as if there was a foreign key sort of relationship with that cascade delete setting, right? But this actually doesn't have an effect on MongoDB itself because MongoDB doesn't support this. The application layer does. So what you'll see is there's a lot of this kind of stuff happening where it's actually the application that defines the structure of the database and the data integrity and so on. So what you need to do when you write apps against these NoSQL databases is you need to have a very strong, clearly defined, isolated data access layer. Right? You need to always go through your classes. You need to always sort of use the functions that you might think of as stored procedures, but now there may be a C# data layer function you call, something like that. Okay? Because it's up to your application to provide some of that structural integrity that used to be in the database itself. So let's see. We have delay in minutes, and then we have let's say this equals int field. And then we have connections, which is going to be a list field of embedded document of connection. Okay. So connection up here, I think that might need to be defined before. We'll go with that. And maybe the connection just has things like flight number, and it has a end city. Where is it connecting to? Okay, clean that up a bit. And now we have our meta here. You can see that we could also define indexes. So I can come in here, and I left this here because I always forget the format. Since it's just a dictionary, it could be called anything. I think I'm missing a curly brace. There you go. So maybe we want an index called find by number. So if we're typically going to look for flights by number, we might want to have an index. So you can do this here. In C#, you have to explicitly call a function that's going to create the index separate of this, but here we have this. And then trips, let's just say, oh, one more thing in the flights here. Passengers, because we're going to book a flight. This is going to be a list field of reference field of customer. All right, so what we're going to store are the primary keys of the customers who are the passengers. Make sense? Okay, so I'm not sure if I need to finish writing this or what goes in there, so we'll find out. So let's go over here and let's load up our flights. So if I uncomment this, and we'll see if I got this correct. It doesn't seem to complain. Okay, so what we're going to do is we're going to create a list. This is like a list of T in .NET. And then we're going to create a bunch of flights and put them into the list. And then we're just going to go through the list and save them. I could save them in order as I do them, but I didn't. So what we're going to do is we're going to create flights. We're going to assign the airline. And this one, I'm going back to our database. You can see I'm pulling out the United. We'll talk about how to do that in a minute. And then I need to save them. So this turns out to be pretty easy to do. I'll say something like for. Python has a for each loop. They call it for, so. Right. So just like Entity Framework, I just call save, basically. But in Entity Framework, I go to the object context or whatever the sort of access layer bit is there. And I call save changes on that, right? And it looks at all the stuff it changed. Here you call save on the individual objects. It doesn't do quite the same type of identity tracking. But anyway, more or less same thing. So we do that. And then same thing for the airlines. I'm going to come down here. Whoops. Oh, if I comment this. All right, so we're going to have some airlines here. You can see they have a name, and that's all they really have. So let's go and just do the same thing. We'll just go for our airlines. We're going to call save. Let's say for A and airlines, a.save. Pretty simple, right? Now, if I come back over here to RoboMongo, and I close off some of this stuff that we were looking at, and I do a refresh, let me zoom for you guys. There is nothing starting with the letter A here, or S, right? There's no SA anything. I'm not going to go to this database, and I'm not going to like open up some sort of design surface or create like a create script. None of this stuff is going to happen. Instead, I'm going to do something different, and hopefully I got everything right and it doesn't crash. Instead, I'm going to call this code. I'm going to call down here. I'm going to call save. And the first time it sees that, it goes, oh, there's no database called SA demo database or whatever I called it, so it's going to create the database. Then it's going to see, well, we're trying to save flights into a collection called flights, and that doesn't exist, so let's create that, and then let's put these documents into it. All right, so let's run it. Does it crash? It does. Fantastic. Arguments must contain a constructor. Hold on. Dun, 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 dun. Reference field. What am I doing wrong here? Really? Oh. Document. Yes. It's unhappy because it knows that it can't put that into these things into where they go. So, all right. I did do this live, didn't I? Embedded document. Oh yeah. If you're going to make it an embedded document, it has to be, I think I said right in my slides, an embedded document. Okay. Done. Now, you notice it was a little bit slow the first time. That's because MongoDB pre-allocates like 64 megs of data plus a little bit more so that it doesn't like, do disk I/O for every like kilobyte that you write to it. So if we go over here though, and I come in and I say refresh, there's now an SA flight DB. Now, every now and then, RoboMongo is crazy and locks up. You may see me have to kill this. But if I go to the airlines, they're pretty boring. Can I go to the fonts here? Oh. Make that bigger for you guys. Not really. Zoom. Okay, well, let's just zoom like this. So you can see those are there. And if I go to these, you can see, let's go find some interesting ones. There we go. This one's pretty interesting. This is some kind of flight from Seattle, Washington to Chicago, and it's UA 2753. And here's the primary key. And it belongs to this airline, which has what I call a weak foreign key reference. There's no enforcement of it, but there technically is some kind of foreign key relationship here that's modeled in the data layer, right? And like all my flights lately, it's delayed. There's no passengers yet because we haven't booked any flights on it. We will. And it has a couple of connections. And notice, remember these are embedded documents. They're simple, I just gave them one property or field, but they could be arbitrarily complex, right? So what's really interesting about this is you can think of these things, like this passenger array and these embedded connections, as sort of pre-computed joins. Right? So there's no joins in MongoDB across documents, but the structure of the document themselves models what are joins in relational databases, right? Like in a relational database, I would have a separate table that has a one-to-many relationship to my connections, and there would be a connections table. But here it's sort of pre-joined. And I have to decide, I'm going to use this often enough that it's worthwhile to store it that way. But if you do, then you get some really interesting performance benefits and simplicity. How do I get the connections for a flight? Well, I get the flight and it has the connections. Problem solved, right? Okay, and in Python, this comes back as a list. In C#, this comes back as a list of connection, right? A generic list that is a connection. Super straightforward. Okay. So we've inserted this data. Now, one thing I want to do when I run this again is I don't want to create the data again, because then we'll have duplicates of everything, and then all sorts of bad stuff happens in trying to do cool demos. So let me go over here to this load data bit, and let's add up here it says bail out if the flights are already loaded. So what I need to do is I need to go to the database and write our first query against it. And the way queries happen in Mongo Engine is you start them from the classes. You go to the class and you write a query off of that. The way they happen in C# is you do something like an object context, like you would for code first entity framework, and those return iQueryable properties, and then you use link against it. Either way, it's pretty similar. So here we'll say if, I'm going to do a query, and the way you do queries is you go to this objects method, I guess, that returns a query set. And then you can ask it questions. That was not where I wanted to go. Like, I can do a count. And that converts to a count operation in the query syntax of Mongo. Similarly, if you did a link statement, a link thing, you did .count on it, it would convert to flights.find.count. And it would say 7. Right? It converts to the index-based server-side thing that's going to happen, right? Both in C# and in Python. So it's sort of more Pythonic to say if not count. So it's kind of truthiness like Java. We'll do a print. We'll say flights already loaded, canceled, return. And we've got to write the same thing for airlines. So let's do a little bit of copy-paste inheritance here, or refactoring. Airlines, airline. Okay, so now if I run it again, you'll see, why did it not bail out? This is the problem. Oh, because I wrote my if backwards. Brilliant. It's the hard problems that I can't solve. There we go. All right, so already loaded, but loaded like 3 times. So let's do this. Let's go over here, and I'll just say drop collection, because I just want to regenerate it. I could write a little query that would delete them, whatever. It's fine. Okay, so we'll run it once, recreates it, run it twice, already loaded. Okay? So now we're off to the races. Let's go do more interesting stuff. Let's go back over here, and let's try to register a new user. Make sense? So maybe that's the next thing to do in our scenario. Like I said, there's these 3 basic web page behaviors that I was thinking you'd model. One, register in the site. Two, booking a flight, so searching for a flight and then choosing it and then putting yourself into it. And three, checking whether a flight is delayed or on time or whatever. All right, so this is a simple one because it has very few dependencies. It's just create a customer object. So we'll say this. We'll say name, and in Python, the way you do like a console write line plus a read line is you say input, enter your full name, like so, and then we'll say C equals customer, and I got to import that in the top. So let's do like this. From core.data.load, data import star. Okay. There's our oh no. Well, that would work, but that's not what I want. From core.data.models import star. All right. Now customer is good. So I can say customer.firstName equals, and let's do a little string split. So if you say your name is, Joe Smith, and get Joe and Smith separately. So I'll say name.split, right? This is just like .NET, split on this, 0. Let's go 1, that'll be last name. Because we're going to run this over and over, and I don't want to keep entering my name, I'll say if not name, print, canceled, return. And then what else do we have? We have the address. So we'll say that's address. Python, you don't use the new keyword. But basically, it's C#. So here we would say what? Street equals 123 Main Street. Let's do it like that. City. I use my city. I'm from Portland, Oregon. Well, we have a state, I believe. Sorry for the U.S. address style. Postal code. And 7123. And then we say c.save with a lowercase s. And then we could say something like print. We just created what? Format. See, I told you it's like C# to JSON. Okay. So let's run this, and it says enter your full name. My name is Michael Kennedy, and I broke something. Apparently, the country is required. So this is interesting. I did break it, but there's no way to say a field is required or not required in MongoDB itself. But in these layers, I can, right? At the application layer, I can say the address field, you must have, what did I miss? Country, all right?
Was that the driver?
This is the driver, yes. It's technically Mongo Engine, which is on top of the official PyMongo driver, but yes, it's in the what they call the ODM. In these document databases, you don't have ORMs because that's an object relational mapper. You just have an object mapper, so sometimes they call it an ODM for object data mapper. But yes, it's in the Mongo Engine.
So in the .NET version, we may have similar functionality, but it might work.
Yes, exactly. And I'll pull up some .NET stuff for you guys. Just remind me, how are we doing on time? We've got 40 minutes. So in like 15 minutes to go, remind me. I'll pull up some C# and show you that as well, but it's quite similar. All right, so let's go over here. They're not identical, but they're similar. So apparently I forgot c.address.country, which is USA. All right, so try again. Michael Kennedy. Cool, we just created this person. And notice after I called save, just like Entity Framework, this happens in .NET and Python, here, c.id is either null, technically called none in Python, or is like an empty value. And then after you call save, it goes to the database, lets the database generate the ID, and then it reads it back for you. So now your object automatically has the ID set. Okay, just like Entity Framework. So basically, the database generates the primary key, and then once you call save, you're good to go. You can generate them yourselves. They don't have to be these object IDs. They could be strings. They could be numbers. But it's harder. You've got to basically do distinct queries, and you got to generate your own IDs, which turns out to be less fun than it could be. Okay, so makes sense? This is the simplest scenario. I want to create a customer and put them in the database. But it's worth looking at that customer over here that we have that we have this nested object, right? That's our embedded document right there. Pretty interesting, right? So think of that as a pre-computed join. Okay. So let's go over here and do some more stuff. Now let's close off these things because they're done and boring. The next thing we want to do is book a flight. So this means we have to go to the database and have to ask it questions like, what flights do you have between these two cities? Okay. Now, just because I'm typing this live and I don't want it to be too complex, you're just going to say, I'm starting from Portland, and it'll show you all the flights that start from Portland. Or I'm starting from London, here's all the flights from London. Like, it's not going to, do routing or any of that stuff. So let's say we'll do a little print. Print booking a flight. And we'll say location equals input, right? Remember console write line, then a read line. What location are you starting from? Question mark. And then I can go to the database and I can do a query against it. Remember, if I'm going to query flights, I do that from the flight class here. I would do that from a flight property on a data context in C#. So I would go to objects, and I say, I'm looking for the, what did I call it in that thing? I called it start city. Right. So I'll come over here and I'll say start city equals location. And that's going to return what's called a query set. So I'll have flights equal this. And then just for now, just really quick, let me just print them out. Print curly 0, curly 1 goes to curly 2. Yeah, okay. We'll do that for a minute. I might need to change this for a second. Flight dot number, flight dot start city, flight dot end the city. Let's just see that this runs in some reasonable way. Well, apparently it doesn't. Try one more time. Okay, so I don't care about that. Let's say I'm going from Portland, Oregon. I just know there's a lot of flights I put in there from that place. So you can see there's two things in the database, Portland, Oregon to Houston, Texas, and Portland, Oregon to Seattle, Washington. And that query took maybe a millisecond, maybe half a millisecond, right? Probably less. And granted, there's not much data here, but you saw with the book example, even with millions of records, it still takes like a millisecond. Okay, so this is pretty awesome. Now maybe I just want to write a little bit of code here to say, let me do this thing called enumerate, which will return both the index and the value in the for each loop. So I can put a, like this, comma I plus 1, and I can ask, okay, let's say, I'll call it num equals input, which flight do you want? And that means the number. So we'll say index equals, let's convert this to an integer, -1, because we're, I think, adding 1, right? 1, 2, 3, not 0, 1, 2. These are humans, not machines. And then let's go over here and let's grab this flight here. So I can say f equals flights of index. Then I can go to the flight and I can say passengers.append. That's like add in .NET. And then I want to put the customer, and let's just assume we have just the one customer, right? They're logged in somehow or whatever. Right. And of course I got to call save, or it's going to be kind of useless. All right. So let's try that. Maybe I got it right. So enter your full name. No, we already got that. Where are you going from? Portland, Oregon. I want to go to Seattle, I guess, flight 2. Now if I go back over to my database and I go to my flights, let's actually go write the query. Number, colon, I don't remember what it was called. It was the one with Seattle. Well, it was UA 2713. Right, but no, it wasn't. Fine, it's just down there. Okay, so let's zoom in. Now look, passengers. All right, sorry, I'll scroll it up for you, maybe. All right, so there's our flight that we booked. We put them in there. All right, you guys getting a sense for it, how this works? It would be exactly the same in .NET. You would get a flight, it would have a list, you would say .add, and it would be done. All right, questions, comments? I'm not done showing you stuff, but it seems like a good break.
When you retrieve all the flights, are they actually mapped to flight objects in Python?
Yes.
How does the ODM know that the object that you're pulling out is actually a flight?
How does it know it's actually a flight?
Because
I could have put junk in here, yeah?
Yeah.
It just tries its best.
So it will
I mean, it knows that I'm wanting a flight because I say flight.objects. So there's a couple of possibilities here. It could be that the thing I'm getting back is something derived from a flight, like this particular ORM and the C# ODM, support inheritance. So it could be like a space flight or a regular flight or whatever kind of, like, it could be a derived class, right? In that case, it actually has the class identifier on the record in Mongo. So it knows how to deserialize it to a superclass or a derived class. So, but what if the thing is not a flight? I don't actually know if it's going to crash or if it's just going to give me a weird flight. We could find out. I could go over here and say, insert document. What do you want? Let's say number equals DL123, and that's it. Nothing else, okay? Save. I was expecting something which I didn't write because I'm still in C# mode or Python mode. Okay, and if we go over here and say view documents, you'll see at the very bottom we have our bad flight. There it is. So let's just go try to get the bad flight and see what happens. It's really up to the ODM to decide, do I crash or do I have empty fields? In C#, if what you were retrieving was a subset of your class, it would just have all the values be default. If it had missing fields, it would crash and go, you're going to load up a document. I'm supposed to be doing something with this like number, but I don't have a number property. And so I'm going to throw it away. But then if you call save, that data is gone, so I'm not going to let you load it. There's ways around it. The serialization in C# is really amazing, actually. Let's go here, and let's just go, let's just do this. Get bad flight. Flight.objects. Whoop. What is it? Number equals F equals, and let's just print bad flight. Yeah? Survey says, we don't know yet. Skip. Which flight do you want? Didn't add my skip. Hold on. All right, try again. Canceled. Canceled. Bad flight. There it is. So number is this, and what else do you get? Nothing. Everything else is missing or whatever.
Could you give a better version the class of that object?
Yeah, no problem. Where is my bad flight? Here, comma, yes, comma, type F, yeah? It is it's a query set. Hold on. I didn't get the actual one out first. Hold on. It may still not be okay. You're right. So what I need to do is a first. Bad class. Now it's a flight. Now if I look at it, it still looks, well, now everything is empty. Yeah, okay, it did deserialize it when I did that bit, but it just left it null, which would be the same C# behavior. Okay?
Can I ask you something else, please?
Yeah, keep going.
You had a function to push a lot of flights into your DB before.
Yeah.
And you had
By the way, I did that inefficiently, just so you know.
Sure.
I should use like a bulk write or something.
Whatever you like. You had a for each save.
Yeah.
If the save call gets interrupted at some point, you probably get an exception in your ODM.
Yes.
But do you know what the state of the DB is? Before
Yes. It either all the way went in, right, on a record by record, document by document sort of mode. It either has the whole document in there or not at all. Because in Mongo, operations on individual records are atomic. You don't have transactions across documents, but within a single document, it is serializable, transaction-based sort of behavior. And there's actually operators like push a customer onto the passengers list. And that would do that sort of transactionally. So you could have that happening like from many threads in parallel, and it would not muck up your data at all. The way I'm doing it, it probably would. If I pull it back and like change the customer list and save it, that could be potentially a race condition. But if I use the update operators, then it would not, right? But it's sort of that reason that the individual document is going to be fine. Chances are if you get an exception, it was never saved, it was never written. But you won't get like half a document. Make sense? Yeah. Yes, sorry, you're next.
In terms of your design, the classes that you define, they're very Mongo specific.
Yes.
Like metadata on how to save yourself, themselves to Mongo, etc. Now, I assume those wouldn't be your sort of domain objects where you've got business logic, etc. So would you have a domain object which then gets translated to this data object, which is Mongo specific, I think, consistent?
Right, so the question is, just for the camera, is would I have separate domain objects rather than just these that I've defined here? You know, if you take a step back and you look at the way the document databases work, they're very, very friendly to the sort of domain-driven design concepts, like the natural aggregate roots and stuff from the whole like Eric Evans DDD sort of time. So in some ways, like, they're quite close to what you would want to put into the database and have as your domain objects. I guess I would probably make them my domain objects only because, you know, there's the risk of bad translations as much as there is anything else, I think. But it depends on the size of your project, right? Are you building a 100,000 lines of code website or a 1 million lines of code website, right? These are probably different choices. If I was building like a service layer where I was returning these over like HTTP RESTful services or something, this is probably not what I would return. I'd probably do something specific for the API that I was trying to build. But for what my app uses, I would probably use this as my domain models, because I can put validation and other stuff in those classes that the ODM doesn't care about, but will be there, right? But what I would definitely do, which I haven't done, is build some separate layer that I use to access the database, like a database service thing I call give me all the flights, search these, like I put all my query logic into one place deep down and just say call this. Because the more free form you get, the more certain types of, like, if you have duplicated data or other conventions that might not be respected all the time. So the more you can put that through a single layer, the better. You had a question as well?
Could I ask a more general question?
Yeah, sure.
Is there any particular reason you might pick Cassandra over MongoDB, or is it all political?
Why would I pick Cassandra over? So Cassandra is interesting. It's what's called a column store database. And so it's closer, I mean, maybe you know better than I do, but it's closer to a relational model with columns and tables than this. And I really like both the lack of structure, and just letting the structure be defined in the class, as well as the sort of pre-computed, most optimal use case nested documents. Do you have thoughts on this, since you guys are using it?
No, we've just used Cassandra, and I'm here to learn more about those
Sure.
types of database.
Yeah, okay, sure.
So that, on that level.
Yeah, I mean, I don't have a lot of experience with it. I kind of know how it works, but just enough to know how it works. Yeah. I know because it seems like Cassandra is much more complicated in terms of setting up. Like here, I just fire up a single server and I'm good to go. Some of the other NoSQL ones require like different processes and machines that watch the clusters that do certain things. Like Whereas this is just like, it can start out super simple and then it can scale if you want to, but you don't have to, right? Yes?
Do you know when you are defining tables in SQL, you define your table and
Yeah.
you need to add another column about inventory statement?
Yeah.
And here you are defining the tables while you're creating the objects on Python, right?
Yeah.
What if you need to add another column?
This is a great question. So if I have to add a column or embedded document or whatever, how do I do that? So there's a couple of ways. One would be to go over to my models, and suppose we want to add a discount rate or whatever, I don't know, which is a float field here, yeah? So if I run this, go down here, you can see I'm accessing the database, and still it has this new field, but if I go and look at the database, it's not in any of the records yet, right? So sort of until I actually make a save back into one of those flights, nothing's going to change. But if I were to call save again on any flight, like if I actually say 2 here, and you go back over and rerun this query, this one, you can see this one. Oh, I guess I never set it, so it left it out. Anyway, I could set it to be something. I didn't say it was required or anything like that. But if I had set a value on it, then it would start showing up, but only in this record. And that can be a little challenging. So what I find that I'll do is one of two things. You can write, like, what would be a migration script up here? I could say, you know, $set discount rate to be 1 or whatever. Like there's a statement I can use to like set that on all the documents, or remove it or rename it or whatever. Or you can just go and change your classes and just load up every class and call save once, right?
You can have this scenario where one of them will have the field, like the column, and the other ones will.
If you don't do one of those two things, you'll easily end up in a situation where there's some of the documents don't have all the fields. Okay, that may or may not be a problem, right? Because your class in memory will have it. It'll have the default value, which maybe is what you would put in the database anyway. And then if you make a change, then it gets saved. So it might be okay, but it gets tricky where you start doing queries into the database before you've resaved them all. And if you were to do a query, find me all the ones that have the default value, well, you'd be missing some if you hadn't updated those records. Whereas if you do something in memory, it looks fine. But if you do it against the database through like .objects or link or something like that, then it goes all haywire. So I encourage you to somehow like do a resave or a modify script. In C#, I almost always do the resave because I have more faith that C# will translate it exactly the way C# should translate it, rather than me tweaking the documents by hand, and then that will serialize right. I know if I call save on C#, that's how it's going to be, and that will deserialize perfectly, right? Okay, so speaking of C#, let me first unzoom. Okay, let me just show you guys some C# because we only have a few minutes left. Do I have some? Yes, I do. All right, welcome to Windows 10. Well, not yet. Got to watch the progress bar. So I'll pull up our website at develop.com, and I'll show you how we're doing some stuff in Link and .NET there, because I know you guys, like 98.2% of you said you're doing .NET. So the ideas are very similar, but let me just show you what that looks like. Okay. Come on. Perfect. Okay, so let's pull up Visual Studio here. And let's pull up develop.com. So we have two major websites that we run on Mongo. We've been running for about 1.5 years, and it's been just a thing of beauty, right? Like we've not had any problems with downtime, corrupt data, nothing. It used to be that MongoDB, under certain circumstances, wouldn't quite flush to disk if the server would crash or whatever. But since like 2.2, we're on 2.6, that's like 1.5 years or something, maybe a year, they have strong journaling, just like SQL Server and Oracle do. So you can go yank the plug on it, and it will survive as well as SQL will. Okay, this is not interesting. So let's go Team Explorer, GitHub. We still store all of our stuff in GitHub. So let's go over here. So we have a separate layer, MongoDB. And in here we have our models. So we have a course. Let me just run it for you really quick while in the background while this is coming up. So here's all of our collections in the database, just like you saw me create these classes. So like here's a course, and these are things we use in our app, but is not required. Right? This I support initialize is some really awesome stuff for hierarchical things in MongoDB and C#, and Python doesn't have it. And I'm thinking of doing a pull request and a patch to Mongo Engine to add this, because this is so cool. So check this out. This private thing doesn't get written, but here's our primary key, it's an object ID. This one we can say, we can add these sort of serialization flags to say only put that in the database if it's not null. Right? We can say it controls the time zone serialization. So when you get it back, is it UTC or is it local time? And here's all sorts of standard stuff. Nullable booleans it supports, integers, strings, blah, blah, blah. A list of embedded documents. So on, right? So super straightforward. I can't get to the Google to get the web fonts, so it looks a little funky. But here you can see is all of our stuff. Like here's the MongoDB class for .NET that I wrote. Right? All this stuff is coming straight out of Mongo, which the font's not loading or freaking it out a little bit. But so here's a class, and when you create one, we automatically populate those lists so that you can just say .add. You don't have to go if it's not null, or if it's null, set the list, right? Just forget it. Just create them all. And then we've got this MongoDB data context, which is somewhere there, wherever that is. And go to course, right? We expose, get me the queryable collection of course. So go to the database, pull back a collection, call it, and it just uses the type name for the name. And it's just an iQueryable of this. And then from here on, it is, it's just on. You can do whatever you want. So if I go find usages of this, there should be like hundreds of them, except they're off the screen. Actually, not so many, because they're all in my repository, like I told you guys they should be. Yes? Come over here and then go away. So for example, like this is a thing of beauty right here. Look at this, you guys. From C and courses, where the ID is that singular default. This should look super comfortable to you guys. And that does the same type of query you saw me write over here, by the way, wherever I wrote it, which is what, this one, where you would just say, I had one, this one right here, right? It does this sort of translation and sends that across, executes it on the server. All right, find course by number, where the number is this, singular default. What else can we find? Here's something slightly more interesting. Go to the course groups, where we're not excluding empties, where the subarray has any items, or the subgroups. The courses, where there are any courses contained within the subgroup, right? That's a nested array of IDs. Or there are any subgroups, that's a nested array of group documents. Like this is for these things up here. So when I click on like .NET, it'll show me like popular, core.NET, and so on. Those are the subgroups. And if I go to like Python, like these are the courses just in there. Make sense? Questions, comments? Yes?
From a developer's point of view, it looks an awful lot like Entity Framework with Code First. I'm quite relaxed about that. What gives me the screaming heebie-jeebies is the slide you had on at the front, at the beginning of the presentation, with the horizontally scaled out databases.
Mm-hmm.
Now, I don't know an awful lot, but my understanding is that they're not replicated databases in the sense that they are exact mirrors of each other, and that there's some kind of strange notion that they will all become in sync over time if you wait long enough.
You
So-
definitely want to go to my talk on tomorrow afternoon because it's all about that. But keep going.
So when I see the classes that have soft references to customer to whatever it was,
Sure.
how does it know where to go?
Sure.
How do I know that if I run against this particular instance, the app will run fine? But on
So-
a different instance, it's not just going to crash in its ass.
All right. For the camera, the question is, first of all, this looks a lot like Entity Framework code first. My comment is, I'm pretty sure they got Entity Framework code first from some of these concepts. They want you to be able to do what you do in Mongo and other document-style databases, where you just create the classes and then Shazam, you're good to go. The problem is with those Entity Framework code first, they're completely awesome, just like Mongo, until you touch the first time, then they calcify, however that is. Then you've got migrations and upgrade scripts, and right, you run into all those challenges that you normally have the second you've created like one of them, right? And you better keep your migration scripts in sync with where you got to go and so on. Now, the other question, really the root of what you're asking is, how do you deal with eventual consistency in MongoDB? Unless you go to significant efforts to create eventual consistency, MongoDB is 100% strong consistency, no eventual consistency. So the way it works is there's two ways to scale out. One, through replica sets, where there's like a cluster, like 3 or 5 databases that are staying in sync. By default, you can only read and write from the one primary, and then the others sort of replicate for durability and failover and so on. But you're not allowed to read from the ones that are doing the replication. You can only read and write from the top one unless you choose to bring in eventual consistency. And if you're doing the sharding, the horizontal scaling for like parallelizing reads and stuff, there's no eventual consistency. There's one server called a Mongo S, a shard server, that controls where the shards go, but you query against it, and it's always got that completely under control. So in the sharded scenario, you don't ever run into that problem. In the replication, only if you do what's called reading from secondaries do you run into this, which is not the default. Make sense?
Kind of. I think I would like to get my hands dirty and play with it.
Yeah, I know. It's all kind of fluffy and weird and different. But by default, one of the things I super like about Mongo over other databases like think Raven or whatever is this strong consistency, just like SQL, just like Oracle. I insert, if I immediately query it, I'm guaranteed that it's in there as long as it said it, put it in there, right? There's no eventual consistency in this world. Whereas a lot of the NoSQL stuff there is, which makes your app super painful to deal with and hard to get that right. Yeah, anyway, this is nice in that regard, that you don't have to worry about it unless you go to extremes. Yes?
Is there a way of putting your hooks in so that you could like do the equivalent of triggers, run some code when a new document gets inserted into a collection?
Is there a way to put in something equivalent of triggers? There's two ways to do kind of what you're looking at, but not perfectly. So the first one is, I didn't really go into detail there, but when I said this bit right here is pure awesomeness, this I support initialize, what this means is the driver, the thing that does the serialization to and from Mongo, when it pulls it out, it's going to run some code that's begin init and end init stuff. So every time your stuff comes out of the database, it lets you reconfigure whatever you got to do, the memory structure, so that it looks how you expect it to look. So here's one hook that you can get into there. I'm sure there's a way, but I don't remember what it is in the reverse direction, like on the serializing in, when you call save. Definitely the way that I have it written on our sites is there's a save function. On this one, we don't do anything interesting on develop.com, but on our other, our online training stuff, learninglineapp.com, I'll say like, okay, if you're trying to save certain types of things, we might run some additional code that pushes this over here, or like fixes up some of these other relationships that you're thinking about. So you can do that there. This whole thing is kind of based on some sort of a C# layer that I have in GitHub. And then the other one is, I can come over here to this. I can say I want to add a function called whatever. Right? I'm not sure if this is a good idea, by the way. But then I can call this some func. And then over here, I can execute that function as a stored procedure, basically. Okay, so you could just, in your data layer, go through some sort of stored procedure that does whatever it needs to do. Now, it's JavaScript, it's not T-SQL, but it's sort of in the server, and it's all good to go. I personally don't like that so much because so much of what's happening in the database is kind of controlled in your app that this one little bit is now kind of isolated from everything else, and it's a little weird.
Are there any performance benefits of using it rather than using it?
Well, if it was doing something chatty, it doesn't have the network latency, right? So maybe that is a reason to do it. I mean, the MongoDB guys are not pushing this as like a great thing to do. But they do support it, right? But it's not like, oh, this is the fix for everything, use these JavaScript functions. They're more like use the drivers, use what's called the aggregation framework. They also support MapReduce, but they encourage you to use something called aggregation instead, which is pretty amazing. Okay, 4 more minutes. Questions?
So can you expand on MapReduce versus aggregation?
Yeah, sure. So MapReduce is a pair of JavaScript functions. One that does sort of a filtering step, and then another does some kind of transformation or aggregating step, right? And it's very popular from things like Hadoop and these other sort of distributed NoSQL things. MongoDB has that, but since about version 2, I think, they've decided that there's a better way to do these things. And they have something called the aggregation framework, which lets you do kind of BI, big data type of questions, as well as answer cross-cutting concerns. So let's look back at our flights really quick. This is pretty awesome that we can see and query into these flights really efficiently, even down into like, find me all the ones that have this connection. We could do that as an indexed high-performance query. But what I can't do is say, database, tell me the average number of connections on a flight. That would be easy, right? Or the maximum number, or the minimum number, or whatever. Some number of, tell me something that takes multiple documents into consideration and sort of does a cross-cutting, or like in this case, across the connection field. You can't do that in the query syntax at all. I'd have to pull all the flights back. Maybe I could project and only pull this bit back, but I have to pull it all back, and then I do the average or max or min on the client, which is wrong. There's a really interesting kind of big data MapReduce-like thing called aggregation that would let you do that on the server using indexes and all the scale out that the servers can have if you do horizontal scaling and so on. And that's called aggregation.
That's MongoDB specific.
It's MongoDB specific. And they think it's better than MapReduce because it's declarative. You say, I want to take things that match this and transform them like that. And you're not writing JavaScript itself. You're writing something more like a SQL language that does it. Okay? So I would look at that. It's really interesting. I can show you guys some examples on how that translates to C# and LINQ. If you come to my talk tomorrow at 4 o'clock, you'll definitely see that. I think you'll see that. So let me show you one more thing, and then I'll take any more questions. So there's a bunch of stuff that we're not covering because we either already covered it or we're just out of time. Don't want to go through the slides. I figure the demos are better. You guys can get the slides off the app, right? You know, the conference app. Please click the survey. You can fill out like a survey. It's like, did you like this talk or not? Basically is the survey, I believe. But what you need to see is this part, this github.mikeckennedy. If I go onto the right network, let me go onto the conference network. I think I just gotten on the wrong one. I'll push these changes. What I just did, I'll push that up there. No, thank you. Well, let's go SA. Perfect. So if I go over to my GitHub app here, I'll just push those changes up. Let's say demos from SA applied NoSQL. Then if we go over here to GitHub, notice, see all these changes right here? These are all from the C# driver. Craig Wilson is one of the guys working on it. And this is all, within the last 24 hours. Pretty awesome. Anyway, what you guys want to look for is presentations. So if you go to github.com, MikeCKennedy/presentations, you will see that there's a conferences, software architect, SA 2014, and this SA Airlines, core data. Why is there's one piece missing here? That's interesting. Not sure why that's missing. Anyway, I'll push that in for you guys to have and play with. And if you want a .NET version, go back here to Dev Week. This is the C# version, if you guys want the C# version of this talk. Okay? All right. I'll figure out why that one file didn't check into GitHub, and I'm happy to answer more questions. But thank you guys for coming to the talk. Hopefully it's good for you.